Hello everyone, welcome back to the disaster management classes. In the last session, we have introduced ourselves to the disasters and what are the various stages in the disaster management. We also looked at what are the general consequences of these disasters or the impact of these disasters on various segments like economy, infrastructure, society, etc. Then we have also seen some of the challenges that are still existing in effectively managing these disasters. Then in the last session itself, we set a goal to cover all different kind of disasters to which India is highly vulnerable and what kind of mitigation and management measures can be taken to tackle these disasters. So that is the goal with which we are going to begin this session. First, we will look at all the natural disasters and we will try to cover some of the important natural disasters where we will understand about what is that disaster, what are the causes and consequences of it, any recent occurrences which are worth mentioning, and then what kind of mitigation and management measures are existing. So this is how we are going to cover each of the disasters. So let me quickly share the screen with you so that we can see what are the disasters that we are going to look at. See, as part of it, first we will be covering some of the important natural disasters. So in the last session itself, we have covered what are the natural disasters. So here I have listed some of them to which India is highly vulnerable. Then on the other side, I have also listed some of the important man-made or man-induced disasters. So once we cover all of them, then we will go and cover the man-made disasters. First, let us begin with, in this session, probably we will cover at least three of them. Okay, first let us see earthquakes, which are very frequent. So every now and then, a small scale and medium scale, sometimes even a severe scale earthquakes does happen, which are causing some sort of damage to India. So let us try to look at what are the what is the mechanism of earthquakes, what are the causes and consequences, and what kind of mitigation measures are there in India, and what kind of efforts have already been taken and what is still can be done. Okay, so with that, let us begin with the discussion on earthquakes. So first of all, what is an earthquake? In simple sense, an earthquake is shaking of earth due to sudden release of certain energy. See, within the interior of the earth, there are some forces. We call all of them together endogenic forces. When those forces release energy in a sudden manner through sudden movements like tectonic movements or some landslides or some sort of deformities, there is energy which is released, and this energy will travel in the form of ripples, or you can say simply waves, in the form of waves or ripples. When this energy is traveling through the crustal blocks of the earth, that will result in shaking or trembling, which we generally call it as tremors. This is what is earthquake. So it's an event where there is a sudden release of energy due to which there is a shaking of earth. Now, the intensity of the earthquake, it directly related to the amount of energy released. So if there is more amount of energy released, or the focus, the point where the energy is released, okay, the point where there is a sudden release of energy is there, that is called focus. And depending upon the depth of the focus, the severity of the earthquake will be varying. So sometimes there can be a deep focus. So if there is a deep focus, so by the time it reaches to the surface where almost all the life form and buildings and everything is there, so by then they get attenuated a lot. But if the focus is a shallow one, then it will cause more disastrous impacts. Okay, so depending upon the focus, and depending upon the amount of energy released, we can classify the severity of the earthquakes. Then how do we measure it? Generally, see, the point where energy is released is called focus, and from here this released energy will travel in the form of ripples, like here it is shown in the picture, and this will travel in the form of waves, which we call it as seismic waves or simply earthquake waves. So they are mainly of two types, like body waves and surface waves, which we broadly study in our geography section. The body waves again further divided into P waves and S waves, primary and secondary waves. Now based on the nature and the travel speeds and how they are actually traveling, whether they are traveling in the perpendicular manner or in the parallel manner to the direction of propagation, so there will be the deformities. And when these waves, let's say the body waves, touches the surface, the point where exactly at the top they touches, it is called the epicenter, and this is the location where there is maximum destruction. And from here these surface waves, they will proceed further, which can be classified again into R waves and L waves. This classification we will see detailedly along with their properties in our geomorphology in geography. Now, how do we measure this? How do we know what is the intensity or what is the level of that earthquake, or whether the earthquake has happened or not? So for this there is an instrument, and this instrument is called seismograph. So it's a simply you can say a drum with a rolling paper on which there will be a very sensitive pendulum bob, and this is highly sensitive to any kind of tremors or shaking or any kind of vibrations in the earth. So the moment there is a vibration, this pendulum bob will start vibrating and giving a seismograph. It's a kind of a graph which you can see it here. Now depending upon the intensity, the amplitude of this seismographic wave, it either high, it will be either high or low. So depending upon it also we get to know some aspects about the earthquake. Okay, so this is the basic of it. Then the measurement. Okay, we have the seismograph to identify it, but in order to measure what is the intensity or what is the magnitude of it, we have different scales. One of the famous scale which you see it in newspapers also whenever there is a earthquake, that is a Richter scale, which measures the magnitude of the earthquake. So whenever there is a earthquake, the its magnitude will be measured on a scale, and depending upon the level, for example, if the magnitude is up to 3, then generally we don't notice or there is no such damage, or you can say recognizable damage. But as this magnitude increases, let's say 3 to 5, you can see there is cracks in the buildings, or you can see the ceiling fans or some furnitures moving. Okay, that means you can actually witness, actually feel that. And if the magnitude goes like 5 or more, then it becomes even more recognizable, more severe, more perceivable. Okay, and if any earthquake, its magnitude is 7 or more, you say that is a severe earthquake because it is going to create lot of damage. The damage may include damage to the buildings, collapsing of the buildings or bridges or any kind of infrastructure. As a result of it, there will be huge economic loss, damage to the infrastructure, and also life loss. Okay, so based on these, either intensity, there is another scale, Mercalli scale, based on the intensity that the residents how they have felt, and this one which is magnitude scale, Richter scale. Based on this we can measure. Okay, now what are the main causes? This is the, you can say, about earthquake. What is earthquake, and what is the mechanism of it, how it reaches to the surface and how it causes damage. But what are the actual causes of damage? See, though we say it is a natural disaster, but there can be some of the man-made reasons as well. So the causes can be natural causes, or they can be man-made causes. For example, under natural causes, the foremost and most important one is tectonic plate movements. So due to endogenic forces, due to convectional currents, different tectonic plates are continuously moving and they are having different interactions. Maybe the convergence or divergence or no kind of a interaction, transform interaction. All of them they release a certain amount of energy, causing earthquakes. So this is the most important and highly significant natural factor. The second reason is volcanic eruptions. See, volcanic eruption is when hot magma pushes out through a vent. So some magmas are there which are generally acidic, which can explode very violently. They can also release a huge amount of energy within a short period of time, resulting some tremors in the ground. So that can be another natural cause. Landslides can also lead to earthquakes. See, which itself is a disaster. See, landslides can cause earthquakes, and earthquakes can also cause landslides. Okay. Similarly, volcanic eruptions are also disasters. Now, whenever there is a landslide, there is a movement of mass weight. When this mass wasting is happening, that can also result in some shaking or tremors in the ground. Okay, it can naturally happen or it can be by man-made reasons. Similarly, aftershocks. These are like a series of adjustments or shocks once the tectonic movement has happened. So after that main tectonic movement, there will be readjustments within the interior of the earth, and they will give, this is what we call it as after shocks. So this can result in sometimes swarm of earthquakes, like a series of earthquakes are very frequent earthquakes in a very short period of time. So before you recover and readjust, there is another earthquake. This kind of things can happen. Then tsunamis. See, tsunami is a both cause and effect. It can cause earthquakes and it can be a consequence of earthquake. Whenever earthquake happens within the ocean, it can result in tsunami, and similarly tsunami can also cause an earthquake. Okay, because this is also energy. Whenever this energy is displaced, that can have a potential possibility to trigger tremors in the earth. Okay, so these are all some of the natural causes. You can explain them depending upon whether the question is simply listing or discussing or examining. According to the question, you can explain and give the examples of it. Then some of the man-made causes. See, one of the important cause of earthquakes by human activity is mining. See, when we mine, particularly deep mining, drilling, and there is another, you can say, unscientific small scale mining called rat hole mining, which you can see it here. Even in India, some parts of northeast uh, do practice this rat hole mining, which has been notified as illegal activity, and it can also lead to collapsing of those mines because there is no protection and scientific exploration is not done. And when they continue to, like a rat no, makes a hole in this manner, they will create a hole and start digging and removing the material, mostly coal and other important resources. So this kind of rat hole mining, when some mines collapse because of instability, or if there is a collapsing of some underground aquifer, they can result in earthquakes. Similarly, constructional activities. Sometimes you can notice it, if there is a big construction going on, huge digging is happening or drilling is happening, then you can feel in the nearby areas, you can feel some shocks. And if it happens in a large scale, or if there is any weak point there which leads to collapsing of the earth, that can trigger an earthquake. Then underground explosions. Sometimes when we are testing some missiles or bombs or some weapons, or if there is an accident underground in a laboratory or in some sort of setup, industrial setup, that can also trigger a huge earthquake. Okay. Then dam induced seismicity. Say we construct dams in order to retain water. Let's say this is a dam holding huge amount of water. Now this water, actually what you are doing, you are obstructing the natural flow of the water. So the kinetic energy is held in the form of potential energy in this dam, and due to this damming, this huge amount of energy is being held. And sometimes when the age of the dam happens, like aging of the dam happens, or if there is any kind of cracks or any disturbance, that can trigger sudden release of this huge amount of energy. So suddenly there is huge potential energy converting into kinetic energy, and there is huge sudden release of energy. This can trigger in the underlying areas or lower riparian areas. It can cause floods, which itself is a disaster, or it can sometimes trigger tremors, that is earthquakes. So this kind of earthquake is what we call it as dam induced seismicity. Then unplanned urbanization and industrialization. So when construction activity happens huge in industrial corridors or industrial locations, which are let's say on loose soils or unstable locations or seismically active locations, and if the construction continues to grow, then the underlying strata may not be able to hold that. As a result of it, there can be subsidence, there can be landslide, or even there can be a earthquake. For example, couple of months ago, there was this case study on Joshimath, where there is a subsidence of the land is happening. Okay. Similarly, some of such examples can be given. Even there is a tunnel collapse, which has resulted in some sort of disaster. So these kind of examples can be given, like unplanned, unscientific urbanization and industrialization, where proper planning has not been made, or proper disaster risk reduction measures are not being taken, or mapping or profiling of the soil to find the properties of the soil. Sometimes soils which are very loose, if you construct huge structures on top of it, it will lead to subsidence or even slanting of those structures, etc., kind of things. Okay. So if it is not done, that is what we call it as unplanned. Then weapons of mass destruction, when they are test fired or when they are detonated, when they are used. For example, we have missiles, okay, or even use chemical bombs, or sometimes even torpedoes which are launched within the oceans. They will also trigger tsunamis. Okay. So all these kind of weapons of mass destruction, when they are either tested, when they are detonated, when they are fired on some other nation or some other enemy, they all of them can have the potential to trigger. See, for example, when we conducted nuclear test uh, way back in 1970s, the test was so massive that some of the tremors were no, it is said that tremors were felt in the nearby surrounding areas. Okay. So this can also trigger an earthquake if that particular area is not seismically stable. Then comes nuclear weapons, accidents. Some of the industrial accidents or nuclear accidents, all of them, they have the potential to trigger earthquakes. So these are all some of the man-made causes. Now, after looking at the causes, what are the recent occurrences which are worth mentioning? Say in India, 2023, we had an earthquake of 5.1 magnitude in the Sikkim and Nepal border. Now, if you take India's Himalayan belt, okay, from Jammu and Kashmir till even your northeastern locations, and some locations like Andaman Nicobar and Bhuj area in Gujarat, Kutch and Bhuj area, they are all highly vulnerable because they are seismically active because of the geographic structure of the Indian plate and its still upward movement. As a result of it, these areas are highly vulnerable. Later we will see it in the mapping. So in these areas, you can see every now and then earthquakes. For example, 2021, there was an earthquake in Assam with 6.4 magnitude, and Mizoram earthquake of 2020 in Champai district with 5.1 magnitude. So these are all some examples of India. Similarly, sometimes, particularly in geography, they might even ask world occurrence of recent earthquakes. So you can give Nepal earthquake of 2015, where India also helped. We have launched Operation Maitri to support Nepal during that earthquake. Then Afghanistan earthquake 2023, very recent one, and this year particularly we can see Turkey and Syria earthquake 2024, Morocco earthquake of 2024, where there were like aftershocks after this. So these are all some examples of recent occurrences. When you are giving, let's say you are giving in 25 or 26 or 27, just that year see what are the recent occurrences and what are the potential causes of it. See, sometimes they might even ask event specific causes. Let's say if we are talking about Bhuj 2001 earthquake, they would ask what triggered it, or if we are talking about Morocco earthquake, what triggered it. So event specific causes can also be asked. So simply, when you are reading the newspaper, when you are covering it up, just cover what triggered what. Okay. Now, what kind of consequence or what are the impacts of earthquakes? See, first and foremost, due to the damage of the collapsing of the buildings and damaging of the infrastructure, there can be huge life loss, human life loss. Similarly, structural damage to the buildings can happen, like infrastructural damage, or it can trigger fires. Some of them can become severe disasters themselves, fire accidents, or forest fire. It can turn into a forest fire, or you can say a fire accident, big fire accident in any particular inhabitation. Similarly, damage to the bridges and highways. For example, if there is a dam and it got damaged due to earthquake, some cracks and etc are there, then in the further events it might even collapse and leading again earthquake or flood. So there is a cascading effect of this disaster into sequence of or series of other disasters. Okay, similarly, damage to the highways. As a result of it, we may lose the connectivity, okay, the physical connectivity, even the digital connectivity due to loss of digital infrastructure, such as mobile towers, okay, or fiber cables, etc. Then initiation of slow failure. See, this slow failure can lead to landslides, okay. So if there is a slow failure, it can lead to landslide, and landslide itself is a disaster which can bury, okay, the low-lying areas or low-lying lives. Okay. Similarly, liquefaction, where there can be saturation of soils with water due to penetration of the water, or it can lead to tsunami, landslides, or flash floods. All of them themselves are disasters which can seriously impact the lives of the people, the no property, the infrastructure, the crops, and environment. Even environmental damage also happens. Many of the species might die. Some of the rare species or endangered species, they might even go extinct. Okay, these are all some of the consequences or impacts of earthquakes. Say submergence of the coastal areas, particularly in the coastal areas, low-lying area may completely submerge below the water. And these are all some of the consequences. Now, what kind of mitigation and management measures are there and are being taken? Okay, we have four stages: mitigation, okay, preparedness, and response and recovery. These are the four stages as part of this disaster management. We have seen mitigation, preparedness, recovery, and response, and then recovery, right? These are the four stages. So as part of response and recovery, see, response is when the disaster is happening or when it is immediately over, what kind of measures you are providing for the immediate relief. So that is not going to vary much, where you have to provide the provisions like food, water, medicines, hospitality, supplies, and connectivity, etc. And recovery is when the disaster happened and how you are going to rehabilitate the people and reconstruct and repair. So that also doesn't vary much. Only you have to take specific precautions for further disasters or further action of the disaster. But what kind of preparedness also doesn't vary. How you are going to prepare yourself to face a disaster, like ensuring all the resources, training the people, capacity building, all of them. So these are all general points. Now specifically for this disaster, what can be done? First and foremost, as part of your mitigation and preparedness, first you must know what are the areas which are highly prone to disasters in India. Okay, so let's say in India, this is what we call it as hazard mapping or hazard zonation, like creating the zones or mapping. Okay, zonation or mapping, you say. So we need to map which locations are highly vulnerable, in which locations there is a high chance that a particular disaster can happen. So accordingly, India is being profiled or is being divided into the zones, seismic zones. So there is no zone 1 in India. So the zones begin from zone 2, zone 3, 4 and 5 with increasing degree of risk. As you are going from zone 2 to zone 5, the risk towards disasters increases, particularly earthquakes. So risk free or relatively less risk zone is zone 2, and moderate zone is zone 3. High risk zone is zone 4, where you can expect frequent earthquakes with medium magnitude, and very high risk ones are zone 5, where you can see very strong or very severe earthquakes, that too in a frequent manner. Now if you look at India, see the stretch, Himalayan stretch, like some parts of Jammu and Kashmir, Uttarakhand, Himachal, and parts of Bihar, Sikkim, and entire northeast Bhuj area and Kutch area of Gujarat, Andaman Nicobar, and some small stretch of like Western Ghats. All of them, they fall under 5. That means they are seismically highly active, and here there can be higher magnitude earthquakes. Then following it, the orange color that you see it here, this is zone 4. Okay, so some small stretches, this is zone 4, where there is compared to zone 5 lesser impact or lesser chance or lesser vulnerability. Then zone 3, compared to zone 4, zone 3 is much better. Then finally zone 2, which you see it in blue color here, and this is the relatively more stable zone. Okay, stable zone in India. So in this zone, there are very low chances that there are earthquakes. Okay, so this is how zonation has been done, and all together you can say zone 4, zone 5 and some parts of zone 3 as well highly vulnerable. So as a result of it, altogether India, almost 59% of India is vulnerable to earthquakes. Now knowing this and marking which districts are highly vulnerable is the first step in reducing their impact, so that you can take some precautionary measures and you can prepare yourself in such locations. So this is the first step. Then what else can be taken? What else has been taken? See, there is national building codes. See, they specify the dimensions, the material quality, and number of columns and beams that are required in a particular building. When you are when you are constructing a building, you need to take certain permissions. So those permissions will only be given if the building structure, the planning follows these specific codes. So thereby making that building, you can say, resilient to disasters or resilient to earthquakes. Even in such areas, if there is earthquake and if these guidelines are followed, the chance that the damage can happen will be less. So this is one important step. Okay, then similarly, the material used for various building construction in different locations, particularly highly vulnerable locations like Himalayas, preferably wood is the material or bamboo is the material, because even if there is collapsing of it, it doesn't lead to much life loss because it is a lighter material compared to concrete. Okay, similarly, there is national program on retrofitting. It was launched in 2014. What is the meaning of retrofitting? See, this is like providing additional strengths to those buildings where initially the building codes were not able to be implemented, or you can say the buildings which are vulnerable to the earthquakes, so they are being given additional strength. Okay, if you look at some locations, particularly in Delhi, I have seen one location like the old Delhi, Chandni Chowk and other regions. Many of the buildings, they are being now retrofitted because they are very old buildings and highly vulnerable, and Delhi is vulnerable to uh, earthquakes because it falls very near to this zone 5 and it is itself in zone 4 region. Okay, so this is called retrofitting. Then RBI directions. See, RBI have given direction to the banks that if any building not meeting the earthquake resistant design is coming for the loans, don't sanction the loans, so thereby putting pressure to meet the designs which are disaster resilient. Similarly, soil analysis, say zonation and hazard mapping, just we have seen. And soil analysis, like what is the property of the soil, whether it is loose or compact, and what kind of structure it has, how much weight it can withhold, this kind of analysis, that is also a very good way forward to reduce it. Then capacity building and capability training to the locals. Say it is those local people who will be experiencing the impact first. So instead of like crying for help, we can train them so that they can take those initial steps. So for this, NDMA guidelines are there. National Disaster Management has released certain guidelines, so adhering to them. Similarly, the kind of first aid and what kind of steps can be taken if they come across any earthquake, so all these training can be given. So this is another good mitigation and management step. Further, creating public awareness and early warning. See, having a very good information dissemination system where the information about happening of any earthquake or any other disaster can be given. See, this information dissemination and early warning will be you can say the topics which you can see it in almost all the disasters, because they are very much integral part of the disaster management. So you can have, say for example, there is GIS information with which now you can track and even track some of the behaviors of animals or the seismic zones or seismic areas or fault areas, so that you can predict before the happening of any disaster. So accordingly, you can take some initial steps to avoid or reduce the impact of it. Okay. Similarly, building schools, hospitals, offices, or any important community building, etc., away from these fault locations, like active fault. So don't develop too much infrastructure or don't have too much activities there, because they will be highly vulnerable. So building such things away from these active faults will reduce the you can say vulnerability. So these are all some of the management and mitigation techniques, and in this direction national disaster management have been giving different guidelines, and they are being adhered. So as a result of it, you can say to great extents the impact has reduced, but still impact is happening, and there is further scope for making it further resilient. Okay, so these are all some of the management and mitigation techniques which are worth mentioning. Now, what can be explored in the future, or what is the way forward from here? What is the need of the hour? That is, see, we can always learn the best practices. Japan is one such country which is highly vulnerable to natural disasters because of its location, the geographical location. It falls in the Pacific Ring of Fire, which is a subduction region which is highly vulnerable to various disasters like earthquakes or volcanic eruptions, etc., landslides. So it has heavily invested in the technology to become disaster resilient. So for example, skyscrapers, like very tall buildings with counterweights. See, even in UAE also you can see, Saudi and Dubai and other locations also you can see these kind of skyscrapers with counterweights. And these, despite being such enormous structures, they are very resilient. Okay, why? Because they are able to maintain their structural stability even after having a disaster, because there are some counterweights and there are some spaces which gives the flexibility in the foundation itself. Okay, so these kind of things can be learned and implemented while we are recovering, okay, in the reconstruction phase. Similarly, say Gujarat, you can also learn from Gujarat reaction. See, after 2001 Bhuj earthquake, immediately after that, see, new town planning with widening of the roads and routes for evacuation, relief works, etc. been included. So this shows the proactive approach towards further such disasters. Okay, then vulnerability mapping. Here you can map the vulnerability of people or community or location, and accordingly your disaster management can be prioritized. Okay, similarly, enforcing seismic codes, conducting capacity building operations. So these are all good steps which can reduce, which can make us resilient, okay, in the disaster management. See, apart from that, there are some international and national legal institutional measures which we can discuss later. Then you can inculcate them or you can add them here to make your answer even better. Okay, now moving on to the next disaster, that is volcano. I specifically did not mention much in the introduction because volcanoes in India are almost negligible, you can say. Okay, because India's geographical location is such that it does not have any severe active volcanoes in the mainland, at least. The only existing volcanoes that you can find it in Indian territory are of these Andaman Nicobar Islands. One of them is Barren Island, which was let's say earlier it was dormant, but it has become recently active, and from since 2004 tsunami it has been active, and every now and then it is like exploding and giving some ash and other material, volcanic material. And it's located, okay, let's say northeast direction from the Port Blair. And one advantage is that this is a not habited island, because the human population is not there. So even if there is a severe explosion, it doesn't cause much of the damage. Okay, damage to the life or property or any other things. Okay, similarly, another volcanic island which is existing is Norcandom, and this is a dormant volcano. That means it's not active, it's not erupting now. So these are the only two existing volcanic islands or volcanoes in India. Apart from that, in the mainland, you don't see any volcanism. So that's the reason why India is not so vulnerable to volcanoes. So that's the reason why we are not covering much, because when the disaster is not there, then there is no emphasis on the disaster management. Okay, maybe countries like Indonesia and Japan, they are highly vulnerable, they may have to focus much on the reduction of the impact. Okay, it doesn't mean that completely India is free. Vulnerability is there because in the vicinity it can trigger, for example, 2004 tsunami was a result of a volcanic eruption of the coast of your Indonesia. So such things can happen, but India is not directly vulnerable to any of the volcanic explosions, and therefore we don't cover much here. Okay, but still notice it, and you can also look at vulnerability or mapping is what only these locations, and thankfully they are not having the any habitations, so not much impact, but we can take some of the specific measures here to reduce the impact of it. Okay, now so that's why I'm not covering much. If you want, let me know, I will cover it, no issue. Okay, now moving on to the next important no disaster, where every now and then you can see the disaster and impact of it in India, that is landslide and avalanches. So I'm covering both landslides and avalanches together because both of them are similar. Mechanism is similar, only the material is going to vary. So we will cover one landslides and the counterpart of it you can take it to avalanches. Okay. See, first of all, what is landslide? As the name is suggesting, it is sliding of the land where some material like you can say soil and rock debris and some pebbles and all. So they will be sliding down the slope under the influence of gravity. So if there is a mass movement down the slope, either due to slope failure or under the influence of gravity and burying it underlying areas, causing life loss and impacting the local ecosystem, this event is what we call it as landslide. See here in this diagram, you can see one of such landslides. I think mostly now you might have had good idea because recently we had an accident landslide that is in Wayanad landslide, which caused death of like more than 350 people and severe impact on it. So we will cover that as a case study. We will take it as a case study and we will try to cover what is the impact and what kind of mitigation can be taken. Okay. So this is what is a landslide. Then what is an avalanche? Say similar mechanism where there is a movement of material due to either slope failure or under the gravity. Only difference is here the material is rather than the terrestrial material like rock debris or soil, it is snow material. So if snow is the material in that kind of landslide or in that kind of slope failure, we call it as an avalanche. Okay, so it is also known as snow slide because that snow is the material. Okay, why it happens? See, in the similar manner, same causes, but with a higher frequency it happens because snow is comparatively more loose and any kind of disturbance can trigger more kind of slope failures in snow ridden areas. So the regions like upper stretches of Himalayas or you can say Himadri Himalayas, they are highly vulnerable to this, and we cover less because the chances that they causing much damage is less because they are less inhabited, and they can severely impact the glacial lakes and leading to glacial lake outburst floods or flash floods or etc. So there we will cover much. So that's the reason why we will be taking landslide portion here and covering all the causes and consequences. Accordingly, you can you can relate it with the avalanches portion. Okay, so this is what is landslide and avalanche and mechanism of it. Now, what are the causes? See, once again, you can divide the causes into natural and man-made. Natural causes include slope. If there is a steep slope, for example, the Himalayan stretches, there is a steep slope because they are fold mountains with ruggedness. So it can, if there is a slope failure, it can trigger a landslide. Or high rainfall. For example, the Western Ghats, they receive orographic rainfall due to monsoons, and particularly the western stretches of Western Ghats, they are highly vulnerable to these kind of disasters like landslides due to rainfall. Even the Wayanad one also, you can say Wayanad 2024, this is because of high rainfall and that has resulted in the mud flow and slowly into landslide. Okay, similarly, earthquakes, like I told you, it's a cause and effect relation between earthquake and landslide. Earthquake can cause landslides and landslides can cause earthquakes, and consequence of earthquakes is landslide. If there is an earthquake, it can also lead to slope failure and it can lead to landslide. Similarly, erosion, soil erosion or deforestation, which you can put it under man-made causes. So if the anchoring provided by the grass and tree roots etc is lost, then the soil will be eroded whenever there is a rainfall, whenever there is this slow failure, etc. So that also result in the landslides. Similarly, gravity. So gravity always attracts towards the center of the earth. So that means downwards. So it can pull that material down the slope, and that can lead to a landslide, or it can be a volcanic eruption. So these are all some of the natural causes. But landslides can also be caused by man-made reasons such as mining, both commercial mining, rat hole mining, any kind of mining. If particularly the material is loosely bound, any mining activities can trigger a landslide. Or construction activity. Okay, so if there is any construction activity, it can also lead to slow failures and landslide. Deforestation, just now I have explained, and human settlements in hill areas, or even practicing of shifting cultivation. Okay, shifting cultivation can also cause uh, these landslides, because in shifting cultivation deforestation will be done. So these are all some of the man-made causes. Now looking at some of the recent occurrences which are worth mentioning, that is Wayanad 2024, which killed over 250 people and caused severe damage, and Silkyara Barkot tunnel collapse in Uttarakhand. Similarly, Joshimath subsidence in Uttarakhand, and Raigad landslide 2023, which killed over 25 people. These are all some of the important recent occurrences. As and when time progresses, if there is any other occurrence, unfortunately, if any other occurrence happens, you add them as an example to it. Okay. Then, what kind of impact is there due to these landslides? Number one, there will be degradation of the soil erosion will continue, and degradation and washing out of this soil, which is a cause and effect as well. Okay, and uprooting of the trees leading to failure in the ecosystem, or imbalance in the ecosystem. Similarly, burying of the buildings and huge settlements. Maybe a village can be buried under the debris which is brought by a landslide, and damage to the crops and plantations. So whenever there is a damage to the crops, so this crop failure could trigger food insecurity, which might even trigger inflation, particularly food inflation, demand driven food inflation. Then frequent roadblocks. Say if there is a landslide, particularly in the upper stretches of mountains where there are some ghat roads or etc., they will be blocked. Then you may have lost your all weather connectivity, or it might even compromise on your security, particularly in the border areas where this difficult terrain and this kind of vulnerabilities are there. If there is a blockage of the road, it can even trigger some security issues. Similarly, injuries and death to the humans as well as animals and many species, loss of fertile land or cultivable land because of burying, or erosion and soil loss can also lead to some of the environmental problems. Then population shifting and migration. So if there is a landslide, and if a village is completely buried, then the population of that village, at least whoever that survived, they have to be relocated, or they will be migrating to some other location. Or if there is a chance that if there is going to be a landslide, people will not be staying there, fearing when this is going to happen. They will of course shift or migrate to some other location. Similarly, it also affects the sources of water. Sometimes even landslides can trigger glacial lake outbursting, or this outbursting can also lead to flash floodings. Okay, these are all some of the cascading effects of landslides. Now, how do we manage them? What kind of mitigation is there? See here, the map which you see, this is National Landslide Susceptibility Mapping. Recently, this landslide atlas or landslide mapping was given by ISRO. So ISRO, using its remote sensing and satellite imagery, it is mapping. This is what we call it as vulnerability mapping or hazard mapping or zonation. So in India, which of the areas which are highly vulnerable? See, areas like the at upper stretches of Himalayas in Jammu Kashmir, Uttarakhand, Himachal, Ladakh, Leh Ladakh regions, and also some parts of northeastern locations and some parts of Western Ghats. Now, once in, I think, either in geography or disaster management, they have asked this question, asking specific reasons to these specific locations for landslides. Now, if you look at here in the Himalayan stretches, what is the main reason? These locations are seismically active. That means here the land is still moving and there are so many faults, seismic faults. Every now and then there are certain adjustments internally happening, leading to either earthquake or landslides. Apart from that, another reason is, see, most of them are very high, steep sloped, rugged mountains because of fold mountains. So the steep slope, and when there is a slope failure, that can trigger. Another important cause, I'm saying specific causes, region specific causes. Another important cause is construction activity and mining that happens in these locations, mining. Then fourth reason is tourism. Okay, so the Himalayan mountains, they are being visited almost every year. Estimation says that roughly about 10 million people, that means 1 crore people are visiting it. Maybe the numbers will be much higher than that. Okay, so as a result of all these reasons, there are landslides every now and then. Similarly, if you come down to these Western Ghats, what are the main reasons? See, here you can also give rainfall as the reason. Northeastern locations, there is intense rainfall, particularly here because of funneling of eastern side and this Bay of Bengal and Arabian Sea branches of monsoons. And here the main reason is intense rainfall in a short period of time. So during monsoons there is orographic rainfall, and that triggers intense rainfalls here, that also causes landslides. Plus huge population density is high, so huge population. So whenever you have huge population, there will be urbanization and huge constructional activities and mining, damming, etc. Okay, so these are all some of the other reasons why there is a high incidence of, or the frequency of landslides is increasing here. Okay, so region specific examples can also be given. Now, how they are managed or mitigated? One is this: first and foremost, you create a mapping, zonation, identify which districts or which locations are highly vulnerable, and then take structural and non-structural measures. For example, say adopting retention walls. You can build a retention wall so that slope failure can be reduced. For example, you can use gunny bags, or you can use concrete material or wooden platform or steel beams in order to provide additional strength to the slope so that slope failure can be reduced. Similarly, we can also take, say, supporting through human structural measures. See, sometimes we can even take sustainable grazing methods where control grazing can be done so that the grass can provide extra anchoring to the soil, or plantation, mass plantation or afforestation can be taken in order to provide extra strength to the soil analysis, so that weak soils or loose soils can be avoided for construction or mining or some other activities. Say mining activities can be regulated, closely monitored and regulated, or setting up eco-sensitive areas within that vulnerable locations, particularly in the high biodiversity rich areas. In the vicinity of it, you can create a eco-sensitive area, or plantation of the trees, which I have already discussed about. Apart from that, there is National Landslide Risk Management Strategy 2019, which addresses all the components of it, under which, say, mapping is there, preparation is there, and also early warning is there, speed information dissemination, and engaging the local people in the conservation of forests and also controlled grazing. Then Geological Survey of India, it has done national landslide susceptibility mapping, and even ISRO, just now we have talked about it, it has launched landslide atlas of India, and NDMA, National Disaster Management, has given certain guidelines. What are the guidelines? Analyzing the soil compactness and properties, and retaining wall construction anchors to the stabilize the slopes, and also controlling the grazing activities, stopping that shifting cultivation or jamming, and environmental impact assessment as part of your Environmental Protection Act EPA. It provides certain powers to the central government to come up with such things like eco-sensitive zones or environmental impact assessments or afforestations, and promoting ecotourism. See, there is a national mission mode project, okay, this on sustainable Himalayan ecosystem. So that also provides ecotourism, okay, and developing institutional capacity and training some of the locals and geoscientists, so that the local geology can be studied and accordingly recommendations can be made. And there is a national mission on sustainable Himalayan ecosystem. This is also a good step. So these are all some of the steps that can be taken to reduce the impact of landslides. So far we have covered so far we have covered earthquakes very elaborately, then volcanoes not much, landslides. On the sidelines of it, you can also say avalanches. So these are all some natural disasters. We have covered the causes, consequences, and what kind of mitigation strategies are existing or can be taken as a forward, as a future step. Okay. Next important natural disaster is floods. So let us try to cover what are floods and what are the consequences, how flood mitigation and management can be done. See, floods are also very recurrent phenomena and a recurrent disaster in India. Every now and then, almost every year, you can see some or other sort of floods. Either it can be normal floods, riverine floods, or it can be urban floods, or it can be flash floods. Okay, so urban floods, flash floods, we will cover under man-made disasters separately. Here, when we are talking about floods, these are like either triggered by cyclones, or triggered by dam failures, or triggered by river overflowing or shifting of the river course, etc. So first of all, what is a flood? See, they are sudden and temporary inundation of a large areas due to overflowing of rivers or reservoirs. So whenever this happens, a large area gets inundated or it gets submerged. This is what we call it as a flood situation. Now, what are the causes? Say there can be intense rainfall, let's say excessive rainfall. Say last 3 years, we have witnessed La Nina situation. This is called triple dip La Nina. So El Nino, it reduces the rainfall in India, but La Nina, it provides more than the average rainfall in India. So whenever there is intense rainfall or more rainfall, that can trigger floods, particularly when our drains are not well maintained, or when our rivers are shifting their courses. So are they are being completely filled with your debris, they are not been properly dredged. So these are all some of the reasons. Then topography of catchment area. So if sometimes the topography of a catchment area of a river is such that there is a natural slope. So whenever there is a natural slope, the water will gush into it, leading to inundation. Then sedimentation of rivers and reservoirs, like too much of debris is getting sedimented. Let's say if the river reservoir or river valley is like this, and the bottom of the river valley is filled with a lot of debris, just say you can say uh, soil or clay or pebbles and all of them, they filled it. Now instead of having the full capacity, now the river is able to hold only this much of water, and if any excess water comes, it is going to overflow and it is going to lead to flood situation. So this is another reason. Similarly, failure of the dams, either due to aging of the dams. Under dam failure we will cover. In India, there are almost 30% of the dams which are aged above 50 years and which are highly vulnerable. Okay, for that there is a project also, and drip project and Dharma portal is also there, and World Bank, with the aid of the World Bank, we are trying to repair and monitor them. Okay, that we will deal it there. Okay, similarly overgrazing. Say when there is a overgrazing, the anchor provided to the soil is lost. Now, whenever there is a rainfall, that water is going to simply run off. Instead of staying and percolating into the ground, it will run off. So that increases the runoff water, finally leading to flood situation. Similarly, deforestation, again, the same link, grazing and deforestation have the same link. And cyclones, La Nina have explained, cyclones is another reason. See, due to climate change, the frequency and intensity of cyclones is increasing. So whenever there is a cyclone, the cyclonic rainfall is going to bring a huge amount of rains, and as a result of it, floods can happen. Particularly in the coastal areas, they are highly vulnerable to this kind of floods. Then shifting of river courses. For example, in India, there are rivers like Son, Damodar, Brahmaputra, etc., which are very frequently shifting their courses, and there are so many small rivulets. As a result of it, flooding. Then drainage congestion and blocking. Say when the drain holes and manholes, they are blocked, there is no draining properly, that can also trigger this kind of flood situation. And then cloud burst, which can lead to flash flood situation, etc. Now, what are the recent occurrences which are worth mentioning? See, Nagpur floods 2023, Assam floods 2024, Vijayawada floods. Who can forget this? This became like a national news, the kind of massive impact that they had. Okay, we will do a case study on this if time permits. Then Yamuna floods 2023. Similarly, India Bangladesh floods 2024. These are all some of the recent occurrences. Okay, so if any other flood that comes in either 2025, 26 or ahead, you just simply add it and see what are the causes behind it. Okay, now what impact is there, or what are the consequences of floods? See, almost 12% of India's land is prone to floods, and that means the frequency is very, very high. And according to National Disaster Management Authority, every year almost 1600 plus people are dying due to floods. So when they are submerged, or when they are stuck in the floods, so these kind of deaths are high. And human and livestock death due to drowning, crop damage. For example, see, this entire crop is drowned and crop loss happens. So croplands triggers food insecurity and inflation. Similarly, serious injuries, and because of water pollution, it can also trigger the outbreak of waterborne diseases like maybe diarrhea, cholera, jaundice, viral infections, etc. Similarly, water pollution. See, when floods happens, the water, riverine water or fresh water, can mix up with drainage water or sewage water, leading to pollutions. Okay, pathogens may spread. Or food insecurity and inflation, means of livelihood is lost, particularly for the coastal communities. When there is a cyclone or floods in the coastal areas, they cannot go for fishing, so their means of livelihood is lost, highly vulnerable. Then during floods, mud huts and buildings built on the weak foundations, they may completely collapse, like kacha houses वगैरह जो हैं, they can collapse. And floods may uproot the trees and can cause damage to the ecosystem. And many of the species, even trees or animals, they may submerge and they may die. Okay, leading to biodiversity loss. So these are all some of the impacts. Now, how the management and mitigation steps can be taken, what have been already taken. See, initially, the first step as part of your mitigation or preparedness is to have identifying, or is to have a mapping, zonation. Like first thing is identify which areas are prone to these floods. For example, here the map shows the areas which are highly prone to the floods. Almost 12% of India's landmass is prone to these floods. Identify them district wise or locality wise, identify them. Then here ensure that you have resources, like prepare yourself. You can provide the resources if there is a flood. Or shelter, like multi-purpose shelter homes can be built in disaster situation or during the flood situation, they can be used as a shelter, and normal situation they can be used as some community building like a school or hospital, or maybe a gram panchayat location, etc. So this is another thing. Then lightning rehabilitation and recovery by assessing the damage. See, जब भी flood होता है, सबसे first आपको you have to provide the relief. So for that you need to have the lightning response. For that you need to prepare yourself to have all the resources like food, water, medicine, supplies and other things. Okay, and then immediately respond and go to that location and provide all these relief measures. Then second thing is assessing, accurately assessing how much damage happened. Maybe you can use drones, you can use unmanned aerial vehicles, or sensing, remote sensing or GIS systems, or maybe a helicopter or plane, through which you can take the aerial tour and see the damage, so that you can assess how much you can say cost is going to happen in the recovery or rehabilitation stage. So assessing quickly and providing that relief to the people. Then no use of state of art technology like drones, etc., in search and rescue operations. This is also part of your response. कई बार ऐसे होता है कि floods में some people are stuck. Now you need to find and evacuate them to a safe location. So for that you can use unmanned aerial vehicles, drones or boats or some other things. Okay, next, early warning. This is also very very important thing. One is forecasting and providing the early warning. So here we have one system, like let's say it uses various sensors, both like satellite based one, okay, and also some of the sensors which are being implanted at the river level to find, let's say there is a sensor in order to identify the water level. So this sensor, as the water level reaches to this, will give the alarm to the data center, and taking this alarm and also with the satellite data like how much rainfall could happen, forecasting all these things, weather prediction and weather forecasting. So you can compile that data and immediately send the signals to the people, like there is, let's say rain gas is there, other sensors are there. So taking all the data, immediately sending the information to the people, are giving the early warning that due to so and so rainfall, or due to cyclone, or due to this there is a flood situation, and immediately evacuate. So this is what we call it as information dissemination. So three things I said. One is forecasting or weather prediction, second is early warning, third one is weather information dissemination. Okay, so these three things, okay, these are all part of your mitigation and also preparedness. Okay, next comes we can also take some of the structural measures, for example watershed management, or building reservoirs to buffer or to reduce these flood situations. Say, let's say a river is constantly flooding, so there you can come up with the construction of the levees. Say, on the banks of the river you can construct some, let's say this is the river and it is flooding here and here, so now here along this you can construct a retaining wall, okay, or a levee. So that even if there is an increasing of the volume or flow, it is not going to flood. Okay, this kind of structural measures. And elevated, building the houses and other important buildings in elevated areas. Let's say this is the normal house building you are making, which is prone to this flooding. So rather than this, you build your house or the building on a elevated platform. Even if there is a flood, so this is not going to flood the house. So this kind of structural measures can be taken, and afforestation and protection of the vegetation, etc. So it's a holistic mitigation plan. Okay, then apart from that, conservation of wetlands. See, wetlands or any water bodies act as a buffer. So they take excess amount of water in times of plenty, and they give water in times of scarcity. So protecting them, conserving them, identifying them. For this we have wetland conservation program also, will cover it under environment. Okay, so this is another thing. Also conserving the floodplain area, protecting it from a encroachment. Okay, say what is floodplain area? let's say this is the normal river, normal conditions, but when the river is overflowing, when there is too much of water, let's say the river is flooding till this area, so this entire region is what we call it as floodplain. And ideally this floodplain should not be taken for any commercial activities. Even agricultural activities are also regulated here. Okay, so this kind of regulatory mechanism to reduce any kind of encroachment into this, and controlling this land use, better controlling, so that some of the activities can be regulated, which can reduce the susceptibility. And linking of the rivers, for example, here shows the possibilities of all river linking projects. So this is going to reduce the flooding, because river linking is going to take the excess water to deficient regions, and it has further positive benefits as well. Some limitations are also there, maybe some other time we will discuss separately on the river linking. So these are all some of the strategies that we can follow, the mitigation techniques, to reduce the impact of the flood and make a particular region highly resilient to floods. So with that, today in this particular session we have covered three major natural disasters, and we studied what are the natural disasters that we covered. One is earthquakes, okay, and we covered landslides. Of course, volcanoes I'm not considering it because we have not completely covered. We just took it because India is less vulnerable to it. Then on the lines of it, we have also seen avalanches. Okay, then the floods. So here we understood the mechanism, the causes and consequences, what kind of mitigation strategies are there, and what kind of way forward is there, and how different stages of disaster management for each of these disasters can be implemented. Okay, so I hope all these points are clear. So with this, let's wind it up this session, and in the next session we can take up further like remaining disasters, uh, and once these natural disasters are done, then we will go for man-made disasters. Once they are done, then we can go for national and international efforts in disaster management and making it no disaster resilient. Okay, that's how we are going to cover. I hope all these points are clear. If it is clear, so do let me know in the comment section. And if you have any queries or any doubts, you can mail me or text me. So let's wind it up here. See you soon in the next session with continuation of the topics. Thank you very much.